Welcome children. Recently we have gone through two sequences, one of which was in arithmetic progression, another was in geometric progression. We saw how to sum up their n terms. In GP we even saw how to find the sum of infinite GP under a certain condition. So today we are going to find the sum of n terms of some special series which are neither in AP nor in GP, but still the sum of their n terms can be evaluated. Starting with sum of first n natural numbers. If we use the notation Sn for it, that is sum of n terms, then the first n natural numbers when we add can be written as 1 plus 2 plus 3 till nth term. Okay, that will be n only. In short, it can be also denoted as sigma n. That means summation of n terms, where n is denoting the first n natural numbers. So first n natural numbers are getting added. Now when we look at this, we find that this is an arithmetic progression. You can see it is in AP. Okay, where first term a is 1 and common difference, that is also equal to 1. So we can use the formula for sum of n terms, which is number of terms divided by 2, then first term plus last term, because both the terms are known to us. So therefore from here we see sum of n terms, or we can say sigma n is coming out to be n into a will be 1 and an will be n. So the sum of 1 and n, we can even write it as n plus 1 divided by 2. So this is the sum of first n natural numbers. Now we are going to use it to find the sum of other cases also, the sum in other cases as well. Okay. So see the next one. It is sum of square of first n natural numbers. When we say square of n natural numbers and their sum, that means we are talking about adding square of 1, square of 2, square of 3 till its nth term, that will be square of n. An easy notation for it is summation n square. That means adding the natural numbers which are of the form square of that particular number. So beginning from the smallest natural number, that is 1. In order to get this, we will be using an identity. You can look at the left hand side of this expression. These are two consecutive natural numbers. We are dealing with natural numbers, so I will use the term natural number. Okay, so cube of x minus cube of x minus 1. So it is of the form a cube minus b cube, and x minus 1 is an integer, or you can say natural number less than x, 1 less than x. Okay, when this is simplified and expanded, it comes out to be this much. Because we are interested in terms like square of 1, square of 2, square of 3 and so on, what we will do is we will keep on assigning values to x starting from 1. So if I replace x by 1, the left hand side reduces to cube of 1 minus 1 minus 1, that comes out to be cube of 0. On the right side it will be thrice square of 1 minus 3 times 1 plus 1. Now replace x by 2. On replacing x by 2, we get cube of 2 minus 2 minus 1 is 1. So cube of 1 is equal to 3 times square of 2 minus 3 times 2 plus 1. You can see we are repeatedly replacing x by its value. Taking another value for it, next natural number, say x is 3, then the equation reduces to cube of 3 minus, this will become 3 minus 1, which is 2. So cube of 2 is equal to 3 times square of 3 minus 3 times 3 plus 1, and so on. Can you see here we are getting our required terms also. this is square of 1, square of 2, square of 3. So we need to keep on assigning values to x till n. So if we do so, for x is equal to n, writing for that now, we get the left hand side as cube of n minus cube of n minus 1, which is equal to 3 times square of n minus 3 times n plus 1. So you can see we have assigned all the values to x starting from 1 to n. So all these natural numbers are being assigned to x. Now we are going to add both the sides. All the terms on the left hand side as well as all the terms on the right hand side. That means cube of 1 plus cube of 2 minus cube of 1 plus cube of 3 minus cube of 2 and so on. So starting from here to this term, everything is going to get added. Now when you look at this, you will see on adding them you are getting cube of 1, you are also getting minus cube of 1. You are getting cube of 2, you are also getting minus cube of 2. So in the same way, if this is cube of 3, in the very next equation, you will get cube of minus 3 also. So you can see this is how the terms are getting cancelled out. So for x is equal to n minus 1, what will happen? If I go for the previous value of x, you will find this will be n minus 1 whole cube minus n minus 2 whole cube, and on the right side it will be thrice of n minus 1 whole square minus thrice of n minus 1 and then plus 1. So this I have written so that you can see this n minus 1 whole cube also gets eliminated. Even this n minus 2 whole cube will get eliminated. So at the end, if you see, finally you will be left with only what? Cube of 0, which is 0, and only cube of n. So on the left hand side I am only left with cube of n. On the right side I will add them like this, like terms I am going to add. So if I add all these terms first, you can see they all have got 3 in common. And what are we left with? Square of 1, square of 2, square of 3 till square of n. Then come to the next term, you will see all these have got minus 3 common. So if I take minus 3 common, we are left with 1 plus 2 plus 3 till n. And in the end, we are having 1 getting added. How many times? X is being assigned n values. With each value, we are getting 1, 1. So this 1 is getting added n times. So on adding all these 1, it reduces to n. Now we need to simplify it in order to get our required result. This is cube of n is equal to 3 times, we can write it as summation of terms like square of n minus 3 times. If you look at this part, this is sum of first n natural numbers which we have derived, and it is n into n plus 1 by 2, and then this plus n. So we'll keep this term on one side, rest all we will shift to the left hand side, and we are going to solve. Okay, so it is cube of n plus 3 times n into n plus 1 by 2 and then minus n. If you look at this right hand side, out of all these terms I can take one n common. Okay, so one of the n is taken common and we will take LCM. LCM will be 2. So n by 2 I can take common, n from the numerator and 2 from the denominator after taking LCM. So this 2 will multiply with the n square which is left. So it is 2n square. This n is already taken common. 3 multiplies with both the terms. So 3n and 3 into 1 will be 3. Look at one more thing. When you have taken n common, we are only left with 1 here. So this 2 multiplies with 1. So minus 2. This will be plus 3 and then minus 2. So plus 3 minus 2 will be plus 1. Okay. So this is what we are getting. Over here, I will cross multiply this 3. When I cross multiply this 3, it multiplies with the 2 in the denominator. So I get 6 in the denominator. And if you look at this term, you will see the center term, middle term can be split and it can be factorized into two factors. The two factors after splitting the middle term will be n plus 1 and 2n plus 1. So this is the sum of square of first n natural numbers. Okay, so this is the result for the required series. Fine, children. Now the next one is sum of cube of first n natural numbers. Okay, so finding the sum of cube of first n natural numbers. So for that I am considering this identity. Let us see what we have to evaluate first. Okay, so we are evaluating to find Sn or sigma n cube, which will be cube of 1, cube of 2, cube of 3 till cube of n. Now for this we are using this identity. So start assigning values to x. We will quickly do this. For x is equal to 1, we get 1 to the power 4 minus 0 to the power 4 is equal to 4 times cube of 1 minus 6 times square of 1, then 4 times 1 minus 1. Now replacing it by 2, we have 2 to the exponent 4 minus 1 to the index 4 is equal to 4 times cube of 2 minus 6 times square of 2 plus 4 times 2 minus 1. Let us take one more value. Say x is 3. So we get 3 with the exponent 4. This becomes 2 with the exponent 4. Then 4 into cube of 3 minus 6 times square of 3 plus 4 times 3 minus 1 and so on. Now we can replace x by n. So for x is equal to n, the identity reduces to n with exponent 4 minus n minus 1 with exponent 4. This will be 4 times n cube minus 6 times n square plus 4 times n minus 1. Now go for the required addition as we did in the previous case. Okay, again you will see most of the terms on the left hand side, they get cancelled out. So all this is getting eliminated. Even 3 to the power 4 will get eliminated. N minus 1 with exponent 4 also gets eliminated. So in the left hand side you will be only left with n with the exponent 4. Now adding the terms on the right side. Okay, like terms you can add together. So I will take 4 common. When we take 4 common, what do we get? This is cube of 1. Okay, let us write them in two different steps. Cube of 1, cube of 2, cube of 3 till cube of n. Okay, then see here, I will take minus 6 common from each and we get terms like, in fact we get a series which is square of 1 plus square of 2 plus square of 3 till square of n. Moving on to the third term, taking plus 4 common, we have 1 plus 2 plus 3 till n. Okay, and how many times this 1 is getting subtracted? It is getting subtracted n times. So that will result into n. Okay, so if you look at these three different series, out of these three, the sum of 2 is already known to us. We have done just now. See, this is n to the power 4. We can shift this minus n to the left. It is plus n. This is 4 times sigma n cube minus 6 times. This is sum of square of first n natural numbers, which is n, n plus 1, 2n plus 1 divided by 6. Okay, and the next term, this is sum of first n natural numbers. So n, n plus 1 by 2. So over here 6 and 6 gets cancelled out. Out of these two I can take 2 can be eliminated. Now you shift this term and this term to the left hand side. So if we do the arrangement of terms, we get 4 times sum of cube of first n natural numbers is equal to, if we look at this, out of these two I can take one n common. So I'm left with n plus n cube plus 1. Okay, and this we are shifting to the left, so it will be plus n plus 1 to n plus 1, and this also it will be minus 2n n plus 1. Okay, so now we need to simplify this right hand side. 4 we will cross multiply later. Even you can factorize this part. Okay, this is in the form a cube plus b cube. We have formula for a cube plus b cube, and what is that? It is a plus b into square of a minus ab plus b. Writing the remaining two terms as it is. Now if you give a look to this equation, you will find lot of the terms can be taken common. We can take n common, we can take n plus 1 common. Let us see what are we left with. This is n square minus n plus 1, okay, from the first part, and from here we have already taken n into n plus 1 common, so only 2n plus 1 is left. What about the later part? You can see we are only left with 2 here, so minus 2. Simplify all these, see if anything can be cancelled out. We'll do that. Okay, we are getting n square only 1, so it remains. Then this is 2n minus n, which comes out to see that the required sum has reduced to n into n plus 1, and the leftover terms, as we were checking, it is n square. 2n minus n is coming out to be n, then 1 plus 1 is 2 and minus 2. So they get eliminated. So this is what we are left with. Now if you look at these two terms again, there is scope for taking n common. So taking n common from here, we get n into n, that is square of n, and then this is already n plus 1, and after taking n common, this is also n plus 1. So we get n plus 1 whole square. Now cross multiply 4. On cross multiplying 4, we get the required sum. That is sum of cube of first n natural numbers. So n square into n plus 1 whole square divided by 4. So these are three special series, and their sum, obtained sum can be used in order to find the sum in case of various series which are neither in AP or GP.